Hi, your Groovy Geological Guy here, and welcome to my Groovy Geological Kitchen. Today, we're going to learn all about 3 different types of rocks. Those 3 types of rocks are sedimentary, igneous, and metamorphic. You know, the groovy thing about rocks is that each one has the ability to change into the other kind. This is called the rock cycle. Did you know that in geological terms, no rock is ever permanent? Because of tectonic movements, heat from magma and weather, as well as extremes of cold and glacier drifts, you will find that no rock ever stays the same over geological time. For example, in one version of the rock cycle, igneous rock can become sedimentary rocks, and sedimentary rocks can become metamorphic rocks. And in other versions, there are cases where sedimentary rock can become igneous or metamorphic can become igneous. And you're wondering, tell us, Mr. Groovy Geological Guy, how is this possible? Well, I'm going to show you how. On the surface of the earth, water and air attack rocks of all sorts and break them down into tardy particles. These rock fragments might collect on a floodplain or in a riverbed, or they might even be swept along by the wind into a sand dune, or just simply collect on the ground. Over time, layers upon layers upon layers of these rock particles, they build up and they start to weigh on each other. Eventually, they fuse together in what we call sedimentary rocks. Now, today, using Starburst candy, I'm going to show you a really groovy way to show you how this works in nature. Each flavor is going to represent a different sedimentary material. So in this model today, here we have yellow or lemon. This is going to represent the sand. Here we have orange. This will be the coral. Here we have pink. This is going to be the seashells. And the red, that's going to be fish bones. So what we're going to do is, I'm going to take these Starburst candy, we'll start with the sand, and I'm going to cut them up into small pieces to represent those fragments that are collecting over time. Kind of like that. Hey everybody, so now, through the magic of television, our Starburst candies have now been turned into particles. Again, the lemon is particle of sand, the orange is particles of shell, and then we have the pink for particles of coral, and the red for particles of fishbone. So now I'm going to show you how sedimentary rock is formed. First, there are particles of the sand, which we have represented here by the lemon. We got particles of the shells. We have particles of the coral. And we have particles of the fish bones that were left. And over time, and with pressure applied, I'm going to use my hands for that. Pressure is applied. Over time and time, out comes what we call a sedimentary rock, where it's formed into one unit. You can see the components, but it's actually one rock. Hey everybody, now we're going to talk about metamorphic rocks. Metamorphic rocks are formed over time when heat and pressure are applied to other types of rocks. In this case, we're going to use the sedimentary rock that we made before out of our Starburst candies. And in our Groovy Kitchen today, the heat that we're going to use is going to come from this groovy iron. What we're going to do is to demonstrate how over time a sedimentary rock may turn into a metamorphic rock. I'm going to take it, put it on this plastic bag here. I'm going to cover it, and we're going to apply heat and pressure, kind of to simulate what would be happening in the real world, potentially maybe with magma heat and pressure, heat and pressure. Okay. Now, you can see that our sedimentary rock from before, which was made of the starburst candy, now has changed to metamorphosize itself. And that's a metamorphic rock. Hey everybody, Groovy Geological Guy here. Now we're talking about the third rock in the rock cycle, and that is igneous rock. Igneous rock is formed when it is superheated beneath the Earth's crust, and it becomes what we call magma, and it works its way through to the Earth's surface where it cools. Once it's cooled, it's known what we know as igneous rock. To demonstrate how that works in the Groovy Geological Kitchen, we're going to take our metamorphic rock that we made before with the starburst, and we're going to heat it in our frying pan. So let's look what metamorphic rock looks like when it becomes superheated and turns into magma. Does that remind you of what might come out of a volcano? It certainly does me. But before it can be igneous rock, it's going to have to cool. So let's cool it. We're going to take it and we're going to put it onto the sheet, and we're going to let it cool. And next time we see you, we're going to have igneous rock. How groovy is that? So now that the magma has cooled, or our starburst candies that we heated on the stove, it has turned into what we call igneous rock. Let's take a look. It's been cooled. You really can't notice any more of the individual particles. It's melted all together in one very smooth and uniform looking brand new rock. Isn't that groovy? The igneous rock. I never had an igneous rock before. That's good. So to recap everybody, remember there's three types of rocks in the rock cycle. The sedimentary rock, the metamorphic rock, and the igneous rock. And over geological time, they are constantly evolving. They never remain permanent. A sedimentary rock can become metamorphic, a metamorphic can become igneous, and igneous can become sedimentary again. So thank you for joining me, your Groovy Geological Guy. Have a great night.